Hello, I'm Frank, and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called 3 V's, Void, Value, and Victory. Or actually, there's no and. 3 V's, Void, Value, Victory by Gadget Green. And here are the rules. We have extended Sudoku rules apply, which means place the digits 0 through 9 in each row, column, and box. However, there will be one digit in each that does not fit. This digit can vary between rows, columns, and boxes and needs to be determined by the solver. So, yes, we have the digits 0 through 9, but it is not a doppelganger. So is it doppelganger? I don't remember if I think it's doppelganger Sudoku. It's not doppelganger Sudoku, which means that you have to have different digits necessarily be missing in each row and column and box. We don't. And we don't have to necessarily have a 0 in each row, column, and box. That's a doppelganger rules. This is just a different extended Sudoku rules version, where we can have the digits 0 through 9 in each row, column, and box, but we don't know which digit is missing. And they could be the same digit, they could be different digits, we don't know. We also have XVs, where digits separated by an X sum to 10, and those separated by a V sum to 5. So, for example, if this were, say, a 0, well, that doesn't work. Say this were a 0. If this were 0, this would have to be 5 to add up to 5. If we had, say, a 3 here, this would have to be 7 for these two digits to add up to 10, because there's an X between them. And all X's and V's are given, so there is a negative constraint involved. So because there's a 3 here, but there's no X's or V's here, these digits cannot be 2 or 7, because there's no X between them and there's no V between them. And if this is 3, these cannot be 2 or 7. And that's an example of how X's, V's, and the negative constraint work. We also have region sum lines, where along each blue line, the digits in each box it passes through must have the same sum. I prefer the way that another setter puts it, where box borders divides the blue lines into segments, which must sum up to the same sum. So, for example, say this was a 3 and a 5. That's not going to work, but say 3 and 4. Then this digit would have to be a 7, because these two digits must sum up to the same sum as this digit, which must sum up to the same sum as this digit, same sum as this digit and that digit. So that's an example of how region sum lines work. We also have Kropki pairs, where digits separated by a black dot must be in a 2-to-1 ratio. So, for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio that is between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so interesting. We have 0 through 9 available, but the only digits which can be next to a black Kropki dot are still the same. It's 1, 2, 3, 4, 6, and 8. 0, if you have it, gives you 0. And 0, if you double it, gives you 0. And you would have a repeat there for in any black Kropki dot if you had that. And 5, 7, and 9 are still the same. If you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, and 18, none of which are digits. So this must be 1, 2, 3, 4, 6, and 8 next to all the black Kropki dots. So let's do that there. We have 1, 2, 3, 4, 6, and 8. To add up to 5, obviously you cannot have 6 and 8 be there. So this is 1, 2, 3, 4, which it adds up with 1 through 4. Same here, 1 through 4 and 1 through 4. So these have to be different 1 through 4 values here. 1 can be with 1, 2. Since this cannot be 6, this can't be 3. And that's all we really have. So this can't be 6, so this can't be 3. So these have to add up to different sums. Or sorry, they add up to the same sum. So this must be the same digit as this. So we'll mark those as yellow. I guess we'll mark this as dark, we'll mark this as red, and we'll mark this as light, I guess. So these are all the distinct different digits to add up to from 1 through 4. Okay. This adds up to 5 also, so this has to be 6 or 8. This must be 1 through 4. It cannot be yellow here. It cannot be light here. This is 1 through 4 guaranteed, because this must add up to 1 through 4. Also, digits that are adding up to 10. This cannot be 1, 9, cannot be 2, 3, 3, 7, so this is 2, 8, or 4, 6. This could be 0 through 5. This has to add up to 10 with another digit, and 5 with this digit, so this cannot be 0 through 5, which means this is 1 through 4, and it must add up to 10 with 6 through 9. So this has to be red and yellow as a pair here. So this is red and yellow as a pair. This could be 0 through 5 there. This must add up to 10 with another digit. That doesn't help us much. This cannot be 4. If this were 4 with another digit, that does not... Oh, 4 and 0 could actually work. Oh, so this could actually be yellow. Okay. And in fact, in box 5, we are guaranteed this adds up to... This is 2 digits from 1 through 4. These must include 1 digit from 1 through 4 because it's either 1, 9, 2, 8, 3, 7 or 4, 6 adding up to 10. So must this. So that guarantees we cannot have 1 through 4 remaining in this box. So there's no 1 through 4 here. This is 6 or 8. This, then, must add up with another digit to add up to 1 through 4. Well, this digit can't be 1 through 4 because we have 2 here, 1 here, and 1 here, requiring a 1 through 4. So therefore, this must be 0 and yellow, adding up to yellow. So this is 0, which makes this yellow, and these are also yellow here. This must be red, which means this can't be red here. That's yellow, which means this can't be yellow here. That's red. So we're going to make this, I don't know, pink? I don't know what we can make it. Yeah, we'll make yellow and pink add up to 10. So then this must be pink to add up to 10 there. So this still could be any of these digits. Yellow is in 6 of the boxes. It's not guaranteed to be in all the boxes, though. That's the thing. Yellow cannot be any of these. That is interesting. Huh. This is 6 or 8, which is only in a 1 to 2 ratio with 3 and 4. Remaining digits in this box, then. This is either going to be 1, 9, and 2, 4, 6. 1, 9, and 4, 6. Or, so this has to be 5 through 9. And if this is 1, 9, and 4, 6, this is 8. If this is 2, 8, and 3, 7, this is 6. So this can never be 6 or 8 here. It's 5, 7, or 9. Light cannot be here, but dark could be here. So light and dark are both here as low digits. Since this can't be 6, this can't be 3. These sum up to a single digit here, which is the same as that digit here. So we're going to make those orange. So these are the same. This cannot be orange here. Orange cannot be here or here. So orange could be here, but we don't know. It might be missing in box 5. Okay, these add up to 10. So it must include either dark or light. We don't know which. This could definitely be 0 and 5. All X's and V's are given, though. We need to keep that in mind. Okay. Orange cannot, well, it could be 0 and 5 there. So let's just make sure we have that in place so that we don't forget that. This must add up to 10 with this, which must add up to 10 with that. So this adds up to 10, this adds up to 10, this adds up to 10. One thing we know is this cannot be 4 and 6. Because if it's 4 and 6, that would force this to be 3 and 8, which is not going to be in a 1 to 2 ratio with each other. Orange cannot be here, here, or here. So if orange is in box 3, it's here. Same with orange in box 5. So if orange is in box 3, it's there. If orange is in box 5, it's there. But we don't have a guarantee. This obviously cannot be yellow and pink adding up to 10. This can't be yellow and red adding up to 10. Or yellow with its counterpart and red with its counterpart adding up to 10. So this must be blue. Sorry, not blue. Dark or light as a low, adding up to 10. This is dark and light as a... Oh, so these are different dark and lights then, adding up to 10. So then let's mark these as green. So this must be then the green here. Therefore, this is, I don't know, we'll make that blue. We don't know which one of these adds up to 10. This can't add up to 10 for that. So this has to then be, cannot be green, cannot be blue. It must be yellow or red. Adding up to 10. It could be yellow pink here. That could certainly work. Or red with its counterpart adding up to 10. This cannot be green adding up to 10. This could be blue, or it's the other yellow and red. Adding up to 10. Oh, that's interesting. If this is 2, 8, what does that make this? This has to be then 1 and 4, right? Because those are the only digits which are in a 1 to 2 ratio with 2 and 8, respectively. So if this is 2, 8, this is 1 and 4, 1 and 4. Therefore, this would be 2, 3 as a pair. So if this is 2, 8, it's in a 1 to 2 ratio with only 1, 4. So then this can't be 1, 4 as a pair. It would have to be 2, 3. So this couldn't be 2. So this would only be 8 there as a possibility. If this is 4, 6, 6 is in a 1 to 2 ratio with 3. And 4 is in a 1 to 2 ratio with 2 and 8. So if we have 1, 4 here, this is 6, 9. This is 6, 9. And these would be different 6, 9s. Or if the 4, 6 here, this would be 3 with 2 or 8. So you'd have 7 here, or 7 here, or 2 and 8. Okay. Therefore, this would be 1, 2, 3, 4, or 8. So this digit cannot be red or yellow. This digit can't be red or yellow, but that doesn't mean anything. Okay, this can't be red or yellow here. This cannot be green adding up to here. Because if this is both green, this must be green, but we already have both greens in box 6. So this can't be red adding up with its counterpart, can't be yellow with its adding up to its counterpart. It can't be green, so this has to be blue. So this must all be blue here. Which means this cannot be blue here. So this must be either red and yellow, red in its counterpart, or yellow in its counterpart, because it can't be both blue here, because that would eliminate that from being blue when it has to be blue there. So it can't be both yellows. This has to be red in its counterpart, which means this is not red. It's yellow and pink here. So this is red in its counterpart. Therefore, this is low here. This cannot be low. It's high. So we have 2 or 4. So red is 2 or 4. Yellow is 1 or 3. Interesting. 6 and 8 then are in a 1 to 2 ratio with 3 and 4, which makes this 8 and 6 and 7 here. 2 and 4 can be in a 1 to 2 ratio only with 1, 2, 4, or 8. So this cannot be 6. This could be 6 here because the counterpart is potentially 6. This can't be 7 though. Pink is 7 or 9. So this is guaranteed to have yellow here. So I think we're guaranteed one of these is a 6, right? If this is 3, 7, that's a 6. If this is 4, 6, obviously that's a 6. So 6 is guaranteed to be one of those two. This cannot be 6 here. 1 would be with 9, 2 and 8 would be with 2 and 8, and 6 would be with 4. So this is 3, 4, 6, 7 as possibilities for the green. This must... We don't know. This can't be green here. I'm trying to think, does this have to be this 6 or 8, essentially? This is 2 or 4, so this can't be 2 or 4 here. Sorry, it can't be 6 here. 2 or 4 could be in a 1 to 2 ratio with more than 2 digits. In fact, it actually has to be with more than 2 digits here. So these are distinct digits. Okay. This is then, these are the same digit. They're both red and low. So this is going to be the counterpart to that. I don't know. What do we make it? Medium? This is red, this is red. These are in a 1 to 2 ratio, both with red. Well, if this is 2, that forces this to be 1 and 4. If this is 4, that forces this to be 2 and 8. Either way, you cannot have 4 remaining in the row, so this cannot be 4 and 6. It's 3 and 7. Since this is 3 and 7, that means this has to be 3. This is 7, this is 6, and that's 4. So all the reds are 4. All the yellows are 1. And all the pinks must be 9. So we don't... This is 1, 9 as a pair. So this is 9. This is 1, 9 as a pair. That forces this not to be 1 or 4. It's 2 or 8. This is 2 or 8. So this must be 2 and 8 and 2 and 8. And this has to be 2 and 8 also. Well, 3 and 2 add up to 5. 2 and 7 add up to 9. 8 cannot add up with 3 or 7 to a single digit. So this is guaranteed to be 2. This is guaranteed to be 8. Which means this can't be 8. That's 6, which makes that 3. No 4 remaining here. So this cannot have 8 there. This can't be 8 here. No 1 here. To add up to 10, it's 2, 8, 3, 7, 4, and 6. This can't be 1 or 3. This can't be 1 or 6. So therefore, this can't be 3. This is 4 within the 2 to 8 ratio. So this has to be 2 and 3. So therefore, dark must be 2 and light must be 3. 3 is in a 1 to 2 ratio with 6. 3 eliminates 3 here, so it's 7 and 3. Therefore, this can't be 7. This is definitely 4. So that can't be 6 here, but this could be 4 and a 2 to... This is definitely has a 4 here. But we don't know. 1 eliminates 1 as possibilities here. So this cannot be 1 and 2 as a ratio. So it's 3, 6 as a pair, which eliminates 3, 6 in the rest of the box. This can't be 3 and 6. So this can't be 3, 7 or 4, 6. So it's 2 and 8. So we have 2, 8 here. 2 is in a 1 to 2 ratio with 1 or 4, but this can't be 4 because of 4 in the column. So that's 1. This can't be 2 or 8. It's 4, which is in a 1 to 2 ratio with 2 or 8, which is in a 1 to 2 ratio with 4. This cannot have 1 or 4, so this has to be a 3-6 pair, which forces this to be a 3-6 pair. 3 and 6 add up to 10 with 4 and 7. This can't be 2 or 8 here. No 1 or 4 here. It's 3-6 as a pair. So that eliminates 2 and 3 here as a possibility. This can't be 4, so this can't be 1 here. This cannot add up to 10 with 1, 9, or 4, 6. This is 2, 8, or 3, 7. 2 and 3 add up to 5. So all the oranges are 5. Okay, which means this can't be 5, so this can't be 0. Remaining digit in box 6 cannot be 2 and 8 because there's no x between them, so this must be 0. Remaining digits in... what's the easiest one? Row 4? Probably, sorry, row 6 could be 2, 4, and 7, right? And this can't be 4, this can't be 2. Okay, that's not helpful. Box 2, we have 0, 2, and 8. No, there should be 3 digits. 0, 2, 7, and 8. Okay, and this cannot be 2 or 8 in the column here. So this is 0, 7 as a pair, which eliminates 0, 7 in the rest of the box. So this is 2, 8 here, which leaves the remaining digit in column 4 as 0 or 9. Okay. Remaining digits in column 5, we have 2, 5, 7, 8. Right, and this can't be 8, this can't be 2, no 5 here. Okay. We have a 3, 6, 3, 6 pair in column 7, which eliminates 3 and 6 in the rest of the column. So this has to be 2, 4, or 8. It cannot be 2, 8 because of the 2, 8 pair in the column, in the box. So this has to be 4, which makes this 0 and 5. 0 eliminates 0 here, so it's 7 and 0. Remaining digits of row 1, we have 1, 8, and 9 possibly. And this can't be 1 because of 8, 1 in the box. This can't be 8 because of 8 in the column, so that's 9. This is 8. Okay. Remaining digits of row 2. Actually, let's do box 3. We have 1, 7, and 9 as possibilities. So now we have a 1, 7, 9 triplet in column 9, which eliminates 1, 7, 9 in the rest of the column. This cannot be 7 or 9, so this can't be 3, 7. It's 2, 8 as a pair. The remaining digit then in column 9 is 0 or 3, and it cannot be 3 because of the 3, 6 pair in the row, so this can't be 3, it's 0. Which means this can't be 0, it's 9. 8 eliminates 8 here, so that's 2 and 8. 2 eliminates 2 here. 8 eliminates 8 here, so this is 2. This can't be 2 or 8, it's 7. Which makes this 5, which makes that 8. Remaining digits in row 7 are 0, 3, and 6, but this cannot be 3, 6 because of the 3, 6 pair in the box, so that's 0. Remaining digits of row 5, we have 0, 5, 8, and 9. Okay, and this cannot be 0, 8, or 9, so it's 5. That means 5 can't be here, 5 can't be here, 8 can't be here because of 8 in the column. 8 also eliminates 8 here, so that's 2, which makes this 7. Makes that 4. 2 eliminates 2 here, so it's 8, 2, and 8. Remaining digits of column 1, we have 0, 5, and 9, and this cannot be 5 or 9 because of 5 or 9 in the box, so this is 0, which makes that 9. There's no 9 here. Remaining digits of column 2, 1 eliminates 1, neither of these could be 1, so this is 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. This can't be 9, it's 1, which makes that 9. Remaining digits of column 2 have to be 3 and 6 and 7. 7 can't be here and can't be 3 or 7, so this is 6, which makes this 3 or 7. Cannot be 3 because of the 3, 6 pair in the row, so it's 7, which makes this 9, which makes that 7. Remaining digits in box 1 are 3 and 6. This can't be 3 because of 3 in the column, so that's 6. Remaining digits of 3 eliminates 3 here, so it's 6 and 3, which eliminates 3 here, so that's 6 and 3, which makes that 6, which makes this 3 and 6. 6 adds up to 10 with 4. Remaining digit in column 8 can be 1 or 7, and it cannot be 1 because of 1 in the box, so that's 7. Remaining digit in row 8 has to be 0 or 9, but it cannot be 0 because of 0 in the box, so that's 9. That leaves this digit as 5 or 7. Cannot be 5 because of 5 in the column, so that's 7. This cannot be 5 and 0 because there would have to be a V between them, so this is 8. This can't be 5 either because there would be a V between that, and so it's 9. 2 eliminates 2 here, so that's 8. No more black dots to find, huh? I guess so. Very cool, actually. A nice little coloring exercise. I feel. Maybe it's just me. I don't think this is easy, though. I feel like this is more challenging level to me. Because I'm only used to this because I've done a whole bunch of XV problems. And I've done a decent amount of problems that include 0, a Sudoku variance that have 0 in it. If you're not used to that, it's going to be actually quite difficult, I feel. So I would probably place this in challenging. But it's a nice little... Yeah, it's a nice little... None of the logic is that difficult, but the execution could be. So I think that's the main reason why I would put this in more challenging level than an easy level. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.